Yeah, sign your attendance. Those come late. All right. We have done principle of impulse and momentum and conservation of momentum, right? So when you talk about principle of impulse and momentum, so principle of impulse and momentum. So when the question will directly mention this one, so you just need to ask yourself, what is the definition of impulse, force and time? But you have to integrate lah. Then what is momentum, mv? So when you write this one, on the left hand side is impulse 1 to 2, then is this a change of momentum? Okay, change of momentum. So you write m1 v1 sorry, m2 v2 m1 v1. Okay, then you move the momentum before, so because you want to change the linear equation into positive sign, so m1 v1 plus integration of your force time equal to m2 v2. Then they come to one more called conservation of momentum. So here mention conservation means something do not change. Then mention momentum, then only you focus on momentum. So change of momentum mv before equal to change of momentum after. Then you see how many object involved. If only one, then one. Then if only you have two, then you have 2 mv on the left hand side, 2 mv on the right hand side. Okay, so this is the important thing for chapter 4. Then today we look into impact. So what is impact? Impact means when two objects they meet together in a very short time. So previously we have shown you the two trains that collide each other, join together, and then the bumper car that bang and then separate. So this one, we're looking at particles now. Particles now. So we have two types of impact. One is central impact. Central impact means the two objects, like you're playing snorkel, they impact along the same impact line. Means they are parallel. They come in the same parallel line. This is called central impact. So on the diagram, you see object 1 will have V1, VA, object B you have VB, but they are in the same line of impact. Then there is a plane of contact. So two objects meet, then there is a center face that meet. So that one is called plane of contact. So this one might come out from your in your test 2 or final exam. So when it comes to the question later, you'll see in your assessment is that the question will only mention the type of impact. They will not give you the diagram. So from the question, you need to identify what kind of impact. First one is central impact, means they have come from the same direction, or not same parallel line or same line of impact. Another one is called oblique impact that we see. This one, they meet at the one point. They come with a certain angle. Not necessarily these two arrow, but they come with a different angle, but they meet at a certain point. They meet at a plane of contact with the angle, the incoming angle. So on the left hand side, so for example, A come with the BB with the angle on the left. B come with the angle with another angle. It is called oblique. Okay. So we will zoom in and then we'll slow down the motion before impact and after impact. We are focusing on particles now. Means particle, we can assume this one as a softball. Softball. So let's say you have two round objects with a different speed. A is faster than B. A is faster than B. So you know that from moment m times v. So A will have moment A, momentum A. B will have momentum B. So this is before impact. So you will see that you predict that A will meet B from behind. Then when they meet each other at the collision plane, you see there is a impulse happen. What is impulse? Force times time, F times time. So you see integration of PP is a force, dt is an impulse. And don't confuse by the arrow. The left-hand side arrow is for B, because you imagine you are B, you collide with someone, the force is punching into your body. So the arrow is pointing towards B, this is for B. Then the right-hand side arrow, this one is for object A. Don't confuse, huh? And then impulse, you have positive and negative. Why positive, negative? Because in this case, or in all the analysis, we always assume we follow the highest, the highest velocity. Direction of positive will follow the your highest velocity. So in this case, A moving faster than B, so positive is to the right. In this case, the force to the left will get negative. Okay, so and you know that when there is an impact, the forces or the impulse meet together, the force will be the same. So you can cancel the impulse here. All right. Then later the question will ask you what is the force for that particular body. So you break the B into this equation, then you solve with equation of impulse and momentum. Okay. So during the impact, it will form deformation, and then they will squeeze until maximum deformation. So when they join together, then the velocity of two bodies will be the same. This is at maximum deformation. Then there's one case they start to separate and go into different direction. This is called restitution impulse. So there is a force that forcing each other to opposite direction. And this one is the central impact. This is for central impact because two bodies come in the straight line of impact. Okay. Then after impact, they separate, right? So in this case, after the impact, B will become, you'll move faster compared to B. In this case, A will slow down, B will move. It's like you playing snooker, right? The white ball will hit the color ball. B will move faster after the impact. So the momentum of A will be small, momentum B will be bigger compared to the before and after. Okay. So we are using the conservation of momentum now. We look before and after. So this is before the impact, after the impact. So if we use the conservation of momentum, right on the whiteboard there, you're focusing on the change of momentum. So mv before equal to mv after. So we have two objects, mva plus mvb before equal to ma after, mb after. All right. Then you can solve the equation. So conservation of momentum, usually to check the general picture before and after. Then the principle of informed momentum is usually during the impact point. These two bodies meet together. Then you use principle of impulse momentum, because at that side you focus on individual body, then you have force. Because in general, if you big picture, then you cancel the impulse. But then you analyze the individual, then you use the principle of momentum and impulse to analyze individual body. It means you have two set lah. You have two set of equation. In this case, y negative because A is looking at the left hand side arrow here. Huh? This force is from A. You imagine your A, you hit by B, there's a force pointing inside your body. So it's pointing to the left. So your impulse is negative. Okay, but for B, you get a positive impulse because your positive direction is to the right. Okay, so this is how you solve lah. Okay, the rest you read. It's the same. There's one new equation you learned today is called coefficient of restitution, which means what is the deformation before and after the impact. It gives you by E restitution impulse divided by deformation impulse. As you can see on the screen here, before or during the deformation, when it is squeezed, you use the A minus P is squeezed in. And then once it's squeezed maximum, then you want to go away, right? Two body want to go away. Then it becomes restitution. Restitution, then you have we represent by R. Okay, so you take restitution divided by deformation. You take the after divided by before. It's like the efficiency. The efficiency, you take the power output divided by input. You take after divided by before. Same concept. So in this case, we take R divided by P, and then you can also, once, how you arrive at this one? You pull this one to here, and then you get this impulse P will equal to MAVA1 minus MAV equal to impulse P. Then impulse R, you move to the right, you move this one here. You make the calculation, you will get the coefficient of restitution will equal to V. V is the final velocity which two body move together, right? Minus VA2 divided by VA1 minus V, right? Okay, so B will also same, but B the sequence will change. The sequence will change based on the formula that you formed just now, right? So look carefully the question, how the behavior. So this is just to show you how to derive the coefficient of restitution. It will not be that direct for this one. Okay. So important is the one that highlight here. Your coefficient of restitution equal to restitution impulse divided by deformation impulse. And this one referring to that particular body only. So you focus on A, then you focus on B, then B. Don't mix between A and B. Okay. So you can combine A and B if you have two body. If you have two body, you combine. Then you can take out the V inside the equation. You arrive at V2 minus VA2 divided by VA1 minus VB1, which means in here, you see that the coefficient of restitution in this case the behavior is A faster than B, then A hit B, then they squeeze, then they separate, then B move faster. In some case, if the case A faster meet B, A become faster, B becomes slower, then this equation cannot be used. You have to derive from this equation. Then you look at the impulse equation. Then you derive one more kind. Don't say, oh, this one is universal. This is not universal. This is for the specific case only. Okay. All right. So on the top is relative velocity before after impact. You take VB the second object, VB minus VA, this is after, this before. You take A minus B. Okay. Again, this is or how I remember it, I always take the big velocity minus the small velocity. Okay. If the object is moved faster after the impact. So you see the big number minus small number, big number minus small number. Okay. So what happens if you have elastic? You have it tell you that the case is elastic impact E equal 1, or a perfect elastic means this one equal to this one. Okay, this one equal to this one, so this one equal to this one. But this one is perfect case lah. If you have a perfect elastic, so if this one 0, mean it's a plastic, or they join together. When they join together, then you'll get 0 here. Okay. Okay. So then you rewrite the conservation equation plus the coefficient of restitution just now, 1 and 2. Then you can see lah. Either the question give you this one, and then you can find the velocity between A and B. Then you substitute back here. Then you find the answer. Right? Okay, another one is oblique impact, which means two objects come with a certain angle but meet at a certain point. Right? So when this kind of question come out, you need to draw the line of impact, the plane of impact, and the angle of impact. Right? So all these have marks if you need to draw the diagram. So, so here you have VA 1 normally you know, VB1 normally you know, angle normally you know, angle 1 also you know, but you don't know the velocity after for A and the angle after it meet. Same with the B. You have 4 unknown. You have 4 unknown. So in this case, you solve this kind of question, the oblique impact, by splitting the velocity vector into x and y axis, including the force. Okay, when it comes to oblique impact, you solve the question by splitting all the vector inside your free body diagram into x-axis and y-axis. Which means in this case, we assume all the positive to the right x-axis is positive, going up is positive. Okay. So you split the diagram on the left to the one that you see on the bottom here, right? So here you split, you focus on A, you do one for A, then you do one for B. Don't mix two body. You see one object first, then you do second object. Don't mix two objects. Don't confuse two objects. Right. But here is still applying the principle of impulse and momentum. Momentum before plus impulse equal to momentum after is still using the same parameter. Okay. Okay. So let's see how we apply the learning today. In this case, something new today, you are giving the restitution constant, which is 0.5. So you're having this diagram. A was released from point A, and then it will hit this B. This bag was tied to a rope. So before you solve, you know this one is a collinear motion. You move in a collinear motion. So collinear motion, automatic draw normal and tangent axis on the object. Then draw velocity and acceleration on the free body diagram, right? Velocity, tangent direction, and then acceleration. You have two, one normal, one tangent direction. Then you start only you start solving. So if released from the rest at position 0 degree, it means 0 is here, 90 degree positive anticlockwise in this case. Right? After falling, theta become 90 degree, means anticlockwise direction. It strike the 9 kilogram box B if the coefficient restitution is given, determine velocity of the back and box just after the impact. What is the loss of energy during collision? Here it asks you about energy. So far we learned about two types of energy only, kinetic and potential energy. In this case, you see, it depends on. You see, although this question do not draw any datum. In this case, my datum will be here. You can put datum on the top or bottom, right? You're still able to solve. In this case, you can put your datum align with the A or align with B. If your datum is below, then your potential energy will be positive because your object is above the datum. If your datum line is aligned with A, then when A hit B, the energy will become negative because your H go down the datum. Okay. So again, identify two types of impact, either central or oblique. This problem involves central impact. Why? Why it's not oblique? What happened to a circle or a curvilinear motion? What happened to your velocity component? The velocity is what? Tangent only, right? So what I mean by tangent in the curve is a straight line. You hit here with the tangent, right? Let's say this is the box. So you object hit the box, your VT is tangent to the circle. So it's actually the line of impact is straight line. You look at the moment they hit, how they hit, okay, how they hit. So this is the central impact. So you draw the back before and after. In this case, my datum is above. Is the height is 1 meter because the radius of the rope is 1 meter. Right. So in this case, you need to recall sometime. You need to recall how to calculate the acceleration. Acceleration, you have two components, an un plus at ut. An is v square over rho. At is v dot or dv dt. Both are tangent direction. And there's an equation to calculate the radius, right? So in this case, your radius is given, so you don't need to calculate that one. So you label position before and after, draw free body diagram, weight always they stay, right, from the center of gravity there. In this case, it do not mention any resistance, so you don't need to calculate the resistance of air. Then after gravity also pointing down. Okay. Yeah. So it's quite direct. Any question for the free body diagram? In this case, quite direct. So you only have one force there. So then, the conservation of energy, you have two types, kinetic and potential. So you write energy before equal to energy after. You have two types. So T1 plus T1 V0, T0 V0 equal to T1 plus V1. Or you can label this one as 1, this one 2. All right, same. Label carefully on your answer. Don't expect your lecturer know what you are writing. Okay. So if your diagram you write 1, 2, but your answer write 0, 0, 1, 1, and then I put question mark, where is 0? Okay. So you put in kinetic mv square, your potential mgh or wh, why positive? In this case, I just put positive lah. Just put it. But when you substitute the value, remember there is a. I should put negative there. Okay. The first one, your kinetic is 0 because velocity start from 0. Velocity 0. Datum 0, right? Then in this case, my datum is below. I should put negative there. I should put negative. So mv square minus something. So I should get a negative sign there. Huh? My h should be minus 1. In this case, my h should be minus 1. Huh? There's a typo error in my solution. So when you rearrange, you'll get positive VA. Okay, make sense? Here square, you have two answers. One positive, one negative. You take the positive one. Because if you take negative means you go another direction. Okay? So there's a typo error in my solution here on the slide. Datum below, it should be negative 1, not positive 1. Okay. So once you're done with the conservation of energy and you look at the question, if the question mentions something energy, very high chances you need to use conservation of energy. Then you look at conservation of momentum. Just before impact and after impact, so I draw the two objects there. A hit B, so B1 start from rest, right? B1 before impact is it do not move, but A it come in with the maximum velocity. Just now you define, right? Velocity, this one, when you hit the box, this is a velocity that coming in and hit the box. Okay. So we have a station body and a moving body. Normally, you follow the motion. So in this case, we assume that AB, when they hit together, they move to the left. We assume. So just after impact, then B will also move. A will move, B will also move in this case. So conservation of momentum. We still use conservation of momentum. Why? We are looking at big picture now. What happened before and what happened after. Okay, we are not so hurried to use the principle of impulse and momentum in this case, because we are dealing with two body. So see two body, we look at big picture. Big picture, we use conservation of momentum. Then then you want to look into individual body, then only you use principle of momentum and impulse, because the force only you can see during the individual particles case. So you have the momentum before, you have two body, mv for A, mv for B, before equal to after. You substitute the value based on your free body diagram. So the before impact, your velocity of B do not move, so 0. M is given for A, velocity A before impact calculated just now, positive to the left, right? So VA2, VB2, you don't know. How you find? You find the second conservation momentum for second diagram, right? So in this case, you calculate using the E value. So in this case, we can directly use this diagram, this value for the impact. So 0.5 VB minus VA divided by 4 point something minus 0. Then from here, you get a linear equation. All right. So you have two linear equations solved simultaneous. You're able to find VA and VB after. Okay. Try to observe the steps that we use and why we use the equation, or when we use the equation. All right, we solve. then you get the direction. So in this case, you find the VA2 is negative sign. So negative sign, it means something. It means opposite direction. You need to tell where is the object A moving after the impact. In this case, you get negative, means A will bounce back. Will start to bounce back to another side of the B with the speed of 0.5. Then B positive, right? Positive means move to the right. And then loss of energy, calculate principal work of energy, in this case, principal work of energy. So in this case, yeah. But anyway, in the assessment, the question will direct you to use a certain principle, okay? Just in case you don't know which equation to use, right? So in this case, we use principle of work and energy. So T1 plus work plus kinetic energy. You put in the work and the kinetic energy equation. So T2 half mv square plus T1 half mv square. Let me see. Yeah, this one you have two body. So T2 you have object A plus object B. All right. Although the velocity one is negative, but you square it, it still become positive. Right. One of it just now you calculate is the VA is negative. You put inside here, you square, you still get positive. Then minus before you only see one because object B was not moving. There's a plus 0 here. This is for object A. Right? You calculate, you get the work is minus something. So when you get a work, or energy loss also means work. Energy loss also means work. So you get a negative. This is inelastic deformation during the case. So you don't need, of course, you don't need to explain whether it's elastic or inelastic. Okay, any question for example 7? Make sense? Okay. Let's look at example 8. Example 8 is oblique impact. So it starts from a certain angle A from given VA, and a certain come with a certain angle. VB come with a certain angle, but above the x-axis with 1. And then you need to find after, what happened after, right? So the given two smooth discs A and B. Smooth means you don't need to consider friction. Having mass given 1 and 2, collide velocity shown. If the coefficient restitution is given, E value is given. Determine the x and y component of final velocity of each disc after collision. So you need to have a good imagination in this impact case. If not, then you go and play some snooker. So in this case, two snooker balls hit together. What is the expected direction of A after impact? What do you think? When two objects meet like this, A will go where? A will go where? Go to this region, right? Hit here, cannot continue one. It will be either this way or that way, right? B also same. Come here, it hit something. Maybe it continue to move, but not that case. Normally, it will just bounce to another case. It's like you hitting a wall. So you imagine what happened to that ball, right? Okay. So this is oblique impact. So resolve the diagram into x and y. All the vector that you see in the diagram convert into x and y direction. In this case, you have vector VA1 and vector VB1. Vector A, you split. Everyone in the class, you know how to split vector, right? This is VA, split to XY. This is V, you split into XY. This is B. All right, but before you do this one, remember where is your principal positive, negative. In this case, all the X positive, negative already given in the diagram. All the movement to the right along X-axis is positive. Y is positive. So you will get negative value for your X and Y component. For B, object B, you get negative sign later. So you split into XY for both VA, VB, right? Anyone you have issue with the sine and cos? No, okay. Go practice if you are still weak in splitting the vector. So that's why you see negative there. Then the rest you read. For unknown, momentum conserve along the line of impact. So you split the A and B into this diagram. A, you use again, when you split and then you focus on individual body, you use principle of impact, impulse and momentum. So you draw momentum plus impulse equal to momentum after. You draw this diagram. Before, momentum plus impulse equal to momentum after. Same with the A and B. Normally the challenges will be you draw the wrong arrow for your impulse. Imagine you are A, you hit by B. Where is the force you're feeling? You're feeling something punching into your body. So there is a force pointing towards your body. Okay, this is a careless mistakes. Normally we have seen in the exam. You will draw something to the right. Look carefully. Where does the A come from and B come from? Focus on this one. Then same for B. Okay, same for B. When they hit and then it will bounce back. So bounce back, the F will be pointing towards B. You have this diagram, you have the formula already. You solve for A, principle of momentum, impulse and momentum. You solve for A and B, you get two equations. Inside the equation, you will see unknown. Right? First equation, you will see three unknown. Second equation, you also see three unknown. You need one more, solved by the restitution coefficient, 0.7. Right? So conservation, you do. So in this case, you start with big body. You look at what happened before and after. Still the same case, like example 7. You draw free body diagram, then you draw before and after what happened. And then the next step, you look at big picture, what happened before, what happened after by using conservation of momentum. In this case, you group in X direction. So if MV in X direction equal to MV X direction also. You substitute, you will get two unknown. Then coefficient of restitution, you pull out this equation, E equal to, in this case, positive to the right. Again, I take big number, or B minus A, below 1, A minus B. I substitute the value, 0.7 equal to relative velocity between 2 divided by VA 2.5 minus VB minus 0.7. Again, positive negative sign, be careful. VB 1 is negative. VB1 in X direction is negative. because it's come from above. And you split, your x is to the left. So negative. So you write this one, then suddenly this one, you accidentally put this one positive. Then you get the wrong answer. So here you have two linear equation. Solve these two simultaneous equation. You will get velocity A after impact, velocity B after impact. This is for x direction only. X direction only. You need to find for y. So for example, your answer for A is you get negative. You need to tell the reader that the direction is pointing to the left for A after impact. Right? Because our general or principal direction is all positive to the left. Then you do the same for y. Right? For y, you will get your VAY2. Okay. Same with another one. Then you find resultant of your vector. All these are vector. So you have x and y, x and y. Before the question give you, do not split. So after you solve, you need to give the resultant of the direction. So you do the resultant of this one. VA 2x and VA 2y. Square this one, square this one, square root. You get the resultant magnitude, speed magnitude. And the angle, you need to refer back. The angle, VA is to the left, VY is to go up, so resultant will go this way. So the n vector will go this way with 50 degree. Okay, we are not we're going to show you how to find the angle already. You already expert already. So you have two vector here. You find the resultant, then you find the tangent. You inverse the tangent, you find 50 degree. Same with the B. You have VB 2x and VB 2y. Square this one, square this one, square root, you get the magnitude 1.41. This one to the left, this one go up, so the direction is, so this one is negative, so it go down. Negative is go down, so it's going this way. Be careful on your positive, negative sign. Normally, careless mistake will be happen in your calculation. You know how to do, but you careless, you make mistakes. All right. Any question for this few example? No, then we have a short break. 10 minutes break. We continue 11:05.